Hey everyone, we are finishing the section on properties of functions, and you're going to find some problems both in your textbook and on my math lab that require a calculator. Okay, and your calculator is going to be very important throughout the course. And so I'm going to go through one of these problems here to give you an idea of how to use a calculator to solve these certain things. So here, the bottom of this page, this is page 91 in your book, it says, use a graphing utility to graph each function over the indicated interval. So there's a function and then an interval. The interval is an x value, okay? And approximate any local max values, local min values, determine where the function is increasing and decreasing, and round answers to 2 decimal places. So this really gets at a lot of the things that we've looked at in this section with the local max, local min, increasing, decreasing idea. But we're going to use a calculator to do that and to get some of those details. And so we're going to take number 64 here, which is f of x equals negative 0.4x to the fourth minus 0.5x cubed plus 0.8x squared minus 2 over that interval from -3 to 2. Okay, so that's what we're going to be focusing in on right here, number 64. All right, so now that we have the instructions, I'll try to write out the answers, but I'm going to use the calculator to determine these things. All right, so I'll try not to get too bad of a glare. All right, so here's my function, there's my interval, and so what I need to do on the calculator, and I'm assuming some of you or most of you should have a pretty good working ability with the calculator, but I am going to show you some things here that may seem a bit elementary to some of you, but I can't assume everybody's at the same place with a calculator. So I'm going to use TI-84 pluses for demonstration purposes here, but if you have a similar type of calculator, it should be very similar. I guess that would make sense. But any of the TI-84s or TI-83s or many of the TI Inspires will have a very similar process, very similar keystrokes and menus. Some of them, some other brands like Casio's may have a bit of a different format to them and may require you to either ask me, maybe we can set up a Zoom session to do a little office hour kind of question answer, or I think the best way to do it is check out YouTube videos, because there's plenty of YouTube videos out there on how to use the calculator. So you could just search, graphing a function on Casio, whatever version you have, and then you could look that up. So anyway, that's probably what I would end up doing anyway, because I'm not real familiar with those calculators, but that's okay. Okay, so anyway, what I want to do is I want to graph this function. To do that, you go to your y equals button. It's the top left button on your calculator, and then you're going to type in this stuff into the y equals here. Okay, now your y equals, you have multiple different equation options here, and that's because you can plot, I think it's up to like 10, you can keep going down, it's up to 9 or 10 different equations. So y1 is going to be negative 0.4x, and this button here next to alpha is your variable button. Then we're going to go raised to the 4th power. Now my calculator uses a superscript. Some of your calculators will not do that. They'll keep everything in line with a little caret symbol. If you have the superscript, you need to hit an arrow, the right arrow, to get out of there. If you don't have that, then it wouldn't be an issue. Negative or minus 0.5x to the third plus 0.8x. Now with the square, if you hit the square button over here, it automatically will pop me out of the superscript, which is nice, and then the -2. Okay, so I have my function inputted. I'll hit enter so it's in there. Now normally when I do a problem, I'm going to go to zoom. So when I want to look at the graph, I go to zoom, and then I typically go to standard. Zoom standard is kind of a nice window because it goes from -10 to 10 in both axes with a scale of 1 for each of those tick marks. The problem is on this one, I don't have a really good view of what's going on in here. It's just kind of, I don't know, the graphics aren't great on my calculator for that. And so I'm going to need to zoom in a little bit more. There are certain functions that this standard window is not very useful with. I think it's okay to start off here, but we're going to need to adjust the window. And besides, the interval we're really looking at is from -3 to 2. And so I don't really need any of the other parts of this graph. So what I'm going to do is I'm going to go to my window, and I'm going to change up those max and min values. So here I have x minimum and x maximum. So I need my x minimum to be -3, not -10. I need my maximum to be, oops, I didn't hit down, to be 2 and not 10. Okay, so -3 to 2. The scale, I could do a scale of 1, but that's really not going to show me much. Maybe I'll go 0.5 just so that I have more tick marks on there. Now in the y direction, I'm not sure what I'm going to need, so I'm going to leave that for right now, and we can come back and experiment with this. So I'm going to hit the graph button so I can go back to the graph. Alright, so I've shrunk in horizontally, but it doesn't really give me a whole lot of information in here because I can't really tell, does this flatten out completely and then go down? Is this level? My graphics are kind of bad, like I said. This could be the case that it just keeps going down, just kind of starts to flatten off, or maybe it comes back up and you just can't really tell from this. So I'm going to try to zoom in a little bit more here, and what I'm going to do is I'm going to pinch in the y-axis, change the max and min, maybe down to like, I don't know, -2 to 2 or something like that. So let's go to the window and let's go -2 to 2 maybe. And that does show me a little bit more. Maybe I'm a little bit too high on this. I should probably bring it down a little bit. But you can kind of see that it does go down and then it comes back up a little bit, which wasn't very clear from the last view. Let me go back to my window and let's drop the minimum down one more, and maybe I'll drop the max down too. That might be a little bit nicer. I like that view. Okay, so yeah, you can definitely tell there's a little bit of a raise in the graph right here. So there's definitely a local minimum or a local maximum here. Comes down, and I'm guessing there's a local minimum in here somewhere, and then it comes back up to a minimum or maximum and then back down again. Okay, so there's definitely 3 local extreme points, 2 local maxes and a local min, I presume. If I were to zoom in even closer in this area, I probably could see that in more detail, but I'm not going to go through and continue messing with the window for right now. Now my instructions asked me to find the values of those local extrema. And so to do that, there's a really nice feature of these calculators called the Calculate menu. It's the second feature of Trace. Now the Trace button will allow you, if I hit it, it'll give me ordered pairs on the graph, but they're not nice ordered pairs usually. They're like crazy decimals that I really can't use. It doesn't give me any precision. I don't know if where exactly the maximum or the minimum are. And so that is useful for certain things, but not for what we're doing. We want precision as much as possible. So I'm going to hit second and then the Calculate menu. Okay, the Calculate menu gives me the ability to find all these different things. We're going to spend a lot of time in this class looking at values. Zeros are actually x-intercepts. Minimums and maximums. We'll even see some intersections as well when we get into systems of equations where there's more than one graph and they cross each other. So for right now, what I want to do is find the local maximum. So I hit maximum, and I'm going to go to this one on the left first. Well, actually, you know what? I already have the, well, yeah, let's do it there. We'll go left to right. I got to hit the left arrow until it gets over there. Okay, so here's what we need. It's going to ask me for a left bound. What does that mean? Well, a left bound, it wants me to surround the local maximum with an interval. Remember, a definition of a local max requires us to have an interval around that point. And so I just need to put an interval on here that contains the local max. It doesn't really matter where. It could be way over here, could be closer, it doesn't really matter. I'm going to put it there because I know that it's to the left. Then it wants a right bound, so that's going to be my other side. So I go to the right of where I think that max is. Now notice when I hit enter, the little arrow popped up there. If I hit enter again, another little arrow pops up. That's the interval in which that maximum occurs. Okay. Now it asks for a guess. It's possible that there's more than one maximum in there, and that's why the calculator wants you to guess at it. I just put my cursor as close as I can and hit enter, and it will tell me roughly where those are. Now it's rounding these off 1, 2, 3, 4, 5, 6 places after the decimal. The instructions here told me to round to 2 places after the decimal. So I'm going to say that there is a local max at the point negative 1.57, comma, negative 0.52. Okay, so that's my first local max. The second local max, I'm going to repeat this process. I go second, calculate. I go down to maximum. And then I scroll it on over. Again, I need a left bound, so I keep myself a little bit left of the maximum. Needs a right bound, so I make sure to go across to the right. And then it wants a guess, so I put the cursor as close to that maximum as I can. And it's going to tell me right here that maximum is at 0.6, round that to 2 places, so 0.64, comma, negative 1.87. Okay, so those are my 2 local maxes. Now I look for a local min. Well, remember, there was a local min. It's over here somewhere by the y-axis. So I'm going to go ahead and find that. Let's see, go second, calculate again. And now I go to minimum. I need a left bound, so I take the cursor to the left. Now I don't know exactly where in here that minimum is, but I'm assuming it's on that horizontal part. It looks horizontal on my graph, but it's not actually. It kind of dips in there. So I'm going to hit enter, and then I'm going to go across the other side. Hit enter, and then a guess. So I just put the cursor somewhere in there. Oh, yeah, that's kind of neat. So here's an interesting perspective. I've got a y value of -2 and an x value that's in scientific notation. If you'll notice that this e-7 is scientific notation for, it represents times 10 to the -7th. This is an incredibly small number. And in fact, a lot of the time when you have one of these, it's because the number in actuality is 0, but the calculator creates some sort of error in the algorithm that it uses, and the value is slightly off from 0. So what I would actually say in this one is that that local min is at 0, -2. Now how do I know that it's 0 and not actually this small value? Well, it's because I know that this function, if I plug in 0, all my x values drop off and the y-intercept is -2. And so I know that if I plug in this negative 4.553 times 10 to the -7th, I'm probably not going to get exactly -2. I'm going to get something a little bit off from that. But again, the calculator is creating some sort of error in its algorithm. So I would use 0, -2. If you see that scientific notation with a really, with a small number like a -7 or -10 or something there, you're going to want to just make that 0 because that's an error probably. Okay, so I've got my local max, my local min. Now, on this interval, I can then determine where the graph is increasing and where it's decreasing. It's increasing from the left endpoint up to that max. So for increasing, I know that it's going to start at -3 and go up to that maximum. Well, that local max was at -1.57. There's also another interval of increasing from the minimum here to the maximum. And so that would be from 0, these are x values, remember, 0 up to 0.64. So there are two intervals where this graph is increasing. There are also two intervals where this graph is decreasing. And remember again, I just want to make sure that this is clear. For this problem, you're only looking on this interval. We're not trying to look for the entire graph on the whole real number line. We're just looking over that interval. So it's a restricted graph. It's really, if you think about sketching this out, going from -3 over to 2, you have a graph that comes up, kind of comes down, up a little bit, and then back down again. And I don't know which side goes down further. I'm just drawing this out, but that's the graph we're looking at. It's not the extended graph with arrows. It's just limited to that interval. So it's decreasing on two of those regions from this maximum, which is at -1.57 over to 0. And then from, 0.64 over to 2. Okay? So those are the intervals of decrease. Now it also asks for the absolute max and absolute mins, I think. Maybe it didn't, but I'm going to go for it anyway. The absolute maximum, if you think about how this graph plays out, is going to occur at the local maximum in the middle here, or the one on the left, sorry. This first one that I wrote down, just based upon how that graph looks. What you really want to do technically is calculate the value at these endpoints of the function. So I'm going to do that. Let's write that out. So I'm going to look for f of -3. And of course, to plug that in, that's going to get really messy plugging that in. But your calculator can evaluate that pretty quickly. Ooh, there's a glare. Okay. Go back to the calculate menu, and you can go to a value, hit value or 1, and then you type in the x value you want. So if I want to find f of -3, I plug in -3, hit enter, and it gives me the output of -13.7. Okay, so I don't have to go through and make that calculation. It's there for me. Then I can do the same thing, value, and I plug in the 2, and that gives me -9.2. So f of 2 equals -9.2. Okay, and so I can tell right away that I was kind of right about this, that the one on the left is further down than the one on the right, just based upon those two values. And so if I want to determine the absolute max and the absolute min, okay, so absolute maximum, all I have to do is compare the y values from the local max values and the endpoints. And whichever one is highest will be my absolute max. So I look at my local max points. I got -0.52, -1.8. Well, this one's higher. It's higher than this, and it's higher than this. This is the highest one. Okay, so that's the one that's going to be my local max point. -1.57, comma, -0.52. Again, comparing the y values from those 4 points. For the absolute min, and this technique will work whether you know what the graph looks like or not, in terms of finding absolute max and min. All you need to do, even if I'm not looking at the graph, all I have to do is compare the y values from the local min and the two endpoints, and whichever one is lowest, which would be right here, will be the absolute minimum. And so that's going to be, the absolute min then is going to be at the point -3, comma, -13.7. Okay, so that gives me both my absolute max, which is right there, and my absolute min, which is right there. All right, everything else falls in between those 2 points. All right, so I hope that gives you a pretty good idea of how to use the calculator to look at those features of a function. Really, the main part of this is to be able to first plot the graph, secondly, establish an appropriate window, and thirdly, use this calculate menu to be able to find things like the minimums, the maximums, the values, and eventually we'll look at zeros again, which are x-intercepts, lots of things that we can do here. But this calculate menu is going to become very important to you as we move throughout the course, so just become familiar with it and comfortable with it, and that should help you out tremendously.